Hello everyone, welcome to video number 4 of AP Computer Science A. In this video, you're going to learn about method overloading, returning and passing objects, and duplicating objects. So first of all, method overloading. So what method overloading is having two methods with the same name but different parameters. So I'm going to create a class to demonstrate it, and you don't need to create a class for this because you can also do method overloading in the main class, but I'm going to create a class called sum. All right, so I'm going to make two methods. So these two methods are both going to be named calculate sum, and that's how you know that there's going to be method overloading. So the first method is going to take an int number as the parameter. And what I want this method to do is calculate the sum of the digits in this number. So to do that, I need a counter to keep track of the sum so far. And I need to scan through every digit of the number. And we can do that using the operators divide and mod. So we can use a while loop, while number is greater than 0. We want to add the last digit of the number to the counter. So counter plus equals number mod 10. And number mod 10 returns the last digit of the number. And after that, we want to remove the last digit of the number. And we can do that by doing number divided by equals 10. And then at the end, we're going to return the counter. So this is the first method. And the second method is going to take a string word as the parameter. And what I want this method to do is calculate the sum of the values of the chars in the word. And what I mean by values of the chars is A is 1, B is 2, C is 3, and so on. So in this case, we also need a counter. And we can use a for loop to iterate through every single character of the word. Right, so we need to account for both if the current character is capitalized or lowercase. And remember that lowercase letters are greater than capital letters. So for the case that the current letter is capitalized, we can determine if it's capitalized by doing word.char at a is less than lowercase a. So if it's less than lowercase a, then that means it's capitalized. And then what we can do is counter plus equals word.char at a minus uppercase a plus 1. So let's suppose that the current character is R. R minus A is 17 because R is the 18th letter of the alphabet and A is the first. And keep in mind that the R is supposed to be a capital R in this case. So then 18 minus 1, and then if you add 1 again, you're going to get 18. So this is how it works. If the current letter is lowercase, then we do counter plus equals word.char at a minus lowercase a plus 1. And if this is confusing to you, then go back to video number 5 of Java Fundamentals. That's where you first learned about comparing and operating on chars. And then we want to return counter at the end. All right, so now let's call these methods. So first I'm going to print sum dot calculate sum of 90433. So it sees that 90433 is an int, and therefore it runs this method right over here. And then if I print out dot calculate of hello, it knows that hello has to be a string because of the quotation marks, and therefore it runs this method. So let's run this. it prints out 19 and 52, and those are the correct answers. So this is how method overloading works. So to demonstrate the remaining topics, I'm going to jump into a new project, and we're going to be using a class called bitset. So bitset is a class that Java has already created for you, and you can use it by doing import java.util.bitset. But we're not going to do this. We're going to create our own bitset class with some of the methods that the normal bitset class has. So let's create the class. So the bitset class, it basically is an array of booleans, except it has a lot more features than just a normal array of booleans. So a variable that we're definitely going to need is an array of booleans, and I'll make it private. I'm going to call it bits. So now the constructor, the public set, and we take an int as the parameter, and I'll call it n. So basically, n dictates the length of the array. So we do bits equals new boolean length n. Alright, so now let's make some of the methods. So the first method we're going to make is called flip. So public void flip, and we take an index as the parameter. So what this method does is it changes the value at the index specified. So if the value at the index specified is false, then it changes it to true. If it's true, then it changes it to false. So the line of code would just be bits index equals not bits index. So if the current element is false, then it sets it to not false, which is true. And if it's true, then it sets it to not true, which is false. So the next method that we're going to make is called get. And it's going to return a boolean. And it's also going to take an index as the parameter. So this is very similar to a getter for a private variable. We're just going to return the value at the index specified. So we want to return its index. And the last method that we're going to make is called size. So it's going to return an int, and we don't need any parameters for this. It's just going to return the length of the array of booleans. So we just return bits.length. So now let's go to the main class, and let's make a method called act. It's going to return a bitset, and it's also going to take a bitset as the parameter. So what the method is going to do is it's going to flip every other element in the array of booleans, starting with the element at index 0. And then we're going to run the method in the main class, and we want to have two bitsets in the main class. One of the original, so what the bitset was like before we ran the method, and one called result, which is the result after we execute the method. So first, let's make the method. Public static bitset act. And we take a bitset as the parameter, and I'll call the parameter key. So we want to flip every other element starting with the element at index 0. So we can use a for loop for int a equals 0, a is less than key dot size, a plus equals 2, key dot flip, and in the end we want to return key. Alright, so now let's make the bitsets in the main method. So bitset original equals new bitset, and I'll just make it length 10, and then bitset result equals act on original. And then after this, let's print out all of the elements in the arrays. So starting with original, so for int a equals 0, a is less than original dot size a plus plus, print original dot get a. All right, and after that, let's skip a line and then do the same thing for result. All right, so now you might think that it would print out false for all elements of original and then true, false, true, false, true, false, and so on for result, but let's run this and see what happens. So you see that for the original, it prints out true, false, true, false, true, false, and so on. So it appears that original and result are the same. And the reason for this is because you can modify objects using methods. So by doing act original, you're allowing this method to modify original. And the way to fix this is to act on, instead of acting on original, you want to act on a new object that's the same as original, but does not point to the same thing as original. And the way to do this is by using a constructor. So let's make a new constructor, and you can do this because method overloading doesn't just apply to methods, you can also use it for constructors, as long as you have different parameters for each constructor. So for this constructor, we're going to take a bit set key as the parameter. So what this constructor is going to do is it's going to create a new bit set that's the same as this bit set key. And the way to do this is, if you had a primitive type variable, for example, private int x, then you would do x equals key dot x. And you would do the same thing for all other primitive type variables that you have. But let's erase this. So since we have an array of booleans, which is an object, as a variable, it's a little more complicated, but it's still pretty simple. So first you need to initialize bits. So bits equals new boolean, and the length of this array would be the length of the array of booleans for key. So you can do key dot bits dot length, and you can also do key dot size. And then you want to copy each element from key over to this new bit set. So for int a equals 0, a is less than key dot bits dot length a plus plus bits a equals key dot bits dot a. All right, and then now going back to the main class, so you change this to, from act original, you change it to new bit set original. And then now let's run this. And this time it works properly. Here's part A of the optional exercise today. Create the price class, which has the public int variables dollars and cents. Make two constructors, one that takes two ints as parameters and sets dollars and cents to them, and one that takes a price as a parameter. Then create the public void add method, which takes two ints a and b as parameters and increases dollars by a and cents by b. Then if cents is greater than 100, make sure that every 100 cents is turned into a dollar. If you want to give this a try, then pause the video here and then keep watching for the solution. Here is the solution. So first we need two public int variables, dollars and cents. And for the first constructor, two ints as parameters, and we set dollars and cents to them. And for the second constructor, we take a price as the parameter, and we copy everything over. And for the add method, we we take two ints as parameters, and increase dollars by A, increase cents by B, and to turn every 100 cents into a dollar, we can do something similar to what we did earlier. We increase dollars by cents divided by 100, and set cents to the remainder when it's divided by 100. And that's it for part A. Part B is to create the food class, which has a public string variable name and a public price variable cost. Make two constructors, one that takes a string and a price as parameters and sets name and cost to them, and one that takes a food as a parameter. Make sure to use the price constructor that takes a price as a parameter. Pause here if you want. Here is the solution. So first we need a public string variable name and a public price variable cost. And then the first constructor, string and the price as the parameters, we set name equals A and cost equals, remember we need to use the price constructor, so we say new price B. And for the second constructor, take a food as the parameter. We set name equals to key.name and cost to new price key.cost. And we're done with part B. Here's the final part of the optional exercise. In the main class, create a food meal 1 with the name lobster and a price of $20.99. Then create the food returning method addDrink, which takes a food as the parameter, adds with drink to the end of the current name, adds $1.50 to the cost, and returns the result. Next, apply the method on meal 1 to create meal 2 without modifying meal 1. Last, print the name of meal 2, a space, and dollars and cents separated by a period. If you've done correctly, then it should print this out. So pause here if you want to give this a try. Here's the solution. So first, we create a food meal 1. The name is lobster. And the price, we do new price 20.99. And then for the method, click static food as the parameter. I'm going to call it item. So first we need to increase the cost of item by $1.50. So we can do item.cost.add. If you remember, add was a method in the price class, 1,50. And then we return, we need a constructor, new food item.name, and then add a with drink at the end, comma, item.cost. And now in the main class, we do food meal 2 equals add drink. And we can't just do meal 1, we need to do new food meal 1, otherwise it's going to modify meal 1. And we print out, first we print out the name of meal 2, and then we add a space, and then we add meal 2.cost.dollars, and then we add a period, and then meal 2.cost.cents. So run this, and it gives out the correct output. Today, you learned about method overloading and returning, passing, and duplicating objects. And for the first time today, you saw a project that involved more than 2 classes in the optional exercise. Since this is your first time seeing this, don't be discouraged if you weren't able to solve it. In the next video, we're going to take a break from object-oriented programming and we're going to learn something new, so that will be fun. See you there!